about that time, should we go ahead and kick off? All right. So welcome everyone to our January edition of Innov8, where we'll be talking about overcoming the privacy restraints for future IoT services, a software-defined edge cloud computing approach with Dr. Dijiang Huang. So we're here to listen to Dr. Dijiang Huang present. He is an associate professor of computer science and engineering at ASU. He has degrees from Beijing University as well as the University of Missouri, Kansas City in computer science and telecommunications. His research interests are in computer and networking security, mobile cloud computing, network visualization, network security, mobile ad hoc networks, etc. His research is supported by federal agencies, including a big long alphabet soup, and organizations such as the Consortium of Embedded Systems, Hewlett-Packard, and China Mobile. He's also the recipient of the ONR Young Investigator Award, HP Innovation Research Program Award, and the JSPS Fellowship. He's a co-founder of Athena Network Solutions and Cynet LLC, and currently leads the Secure Networking and Computing Research Group here at ASU. So we're pleased to have him here with us tonight, and I'll go ahead and turn it over to Dr. Huang.
Okay, thank you, Lisa, Michelle, for the introduction. Okay, so now let me share my screen. I can take over on my side. Let me share my slides here. Okay, so can everybody see my slides? Share the window?
We can.
Okay, great, wonderful. Let me make the full screen. Hi, everybody. Again, my name is Dijiang Huang. As Michelle introduced, I won't cover those parts. So basically, my current research is on the cloud computing, cybersecurity, and also recently we have been investigating into the IoT security. So part of the presentation is based on the collaboration with UTO, especially James McCandy, so who has been working with me to investigate into a new IoT trust platform, and we're working on submitting NSF proposal and also establishing the prototype to demonstrate how this new trust platform works. So today, I just want to present some recent hours research outcomes, and most of the work are very new. So you may not be able to see there's off-shelf products, so hopefully this can generate some of new ideas and new direction, especially from application aspect. We want to see how this work can benefit our future IoT-based services. So first, we want to see some motivation slides, and in the next few slides, I'm going to show mainly from the IoT and the security and also machine learning, artificial intelligence perspective, what is the new challenge and what is the current issues we need to address. So first, let's see. Next slide. Oh yeah, here we go. Yeah, so this slide shows I get from the Gartner's 2020 projection regarding to the IoT and the machine learning security. So I just want to highlight some part of it because it's quite a lengthy report, so I capture the relevant content in this slide. Particularly, it says privacy is becoming a discipline of its own. Right? So usually mostly we consider privacy as a feature of the security. Right? So when you develop solutions, you consider, what is a property of the in terms of what is security property in terms of privacy. But today, looks like privacy become very important, especially if we have a lot of IoT devices has been deployed, right? So those IoT devices can sense, can record, can monitor the environment, but also they can be used to monitor humans, right? So then this significant privacy concerns come into the picture. So another issues right now we are facing is the AI create a new security responsibility for protecting digital business initiatives. It will require a cross-border set of use cases, right? So traditionally, mostly when we look at into the security or privacy solutions, usually we just look at a specific application, right? So we rarely look at from the entire platform, framework, or infrastructure aspect to see how we can build up a platform or infrastructure to better support privacy. So that can allow us to consider the privacy or security as a fundamental design principle, right, before we deploy a real application usually on top of it. Okay, so that's why we want to see from system-wide, architecture-wide, how can we build up a scalable and also expandable privacy preservation infrastructure to support our future IoT-based services. Just like a motivation example. Next slide. Okay. So actually, this slide I borrowed from James McCanney. So he shared me this ASU Smart Campus City Region Initiative back in 2019. The idea is how we can build a smart and digitalized campus, and based on that prototype, we can establish on campus how we can expand the solution to a larger scale, such as from the city or from the regional scope. Okay, so here just a picture. So for those of you, I guess most people here are familiar with ASU campuses. So here it's very quick. I want to show you we have several major campuses in this metropolitan area. And this is some data back in the 2018 regarding to the total number of students, number of faculty, number of resident students, organizations, and the total number of visitors. And significantly, we have quite a number of incident reports every year. And so that shows it's a very active region. And so focus on these multiple campuses in this metropolitan city. So to address these problems, and we want to see how we can improve our on-campus IoT systems to support better digital life. Right. So there's some vision statements, and I just highlight some statements, and you can see we want to focus on the campus, city, and the region scope, and because we want to see how to use data we can collect, which is respecting to the privacy and make it as a basic concern, and to preserve the digital equity is another concern, right? So these are two main motivations, help us to lay out what is a good design principle we should follow, right? In order to protect the data privacy as well as the data equity, right, or data rights. So the best innovation should start with the quality data, right? Because we call it a data science. Okay, so this is called. So basically, the data quality is come out with a better data analysis model, right? One challenge right now we are facing is that we have a lot of IoT devices has been developed or deployed all over the places. But the problem how to utilize this data is questionable. we can emulate a city or region IoT structure. Just consider there's multiple organizations. They have their own control domain to monitor and collect data. But however, if you ask them, can we use your data to use our machine learning algorithm? So there's a lot of data like the machine learning companies, right? So they try to get data to build up a data model, and then in turn they can give the data model back to the domain user to let them to have better data collection, analysis, and processing, right? But however, due to the privacy concern, we have this, we call it a data island problem, right? So you collect a lot of data, but you store in your own repository, and you are free to give out, right? From the data owner side, they are free to give out the data for the machine learning company, right? How to break this barrier, right? So most of our current research, especially I know a few people in our school, when they're working with some like external institutions such as Mayo Clinic or other institutions, the way they want to access data, they need to be physically be there and running everything on their own system, right? Of course, they need to sign a lot of documents, to make sure they will not purposely release data to outside. Because the main issue is that if the data owner gave out the data to the data user, such as the machine learning company, they just lost control of it. Okay, so they can use the data and resell the data to anywhere, right? So it's hard to preserve the data rights. So we are facing this challenge, right? And other issues like because the IoT is all over the places, we need to answer what, where, and how, right? In order to use the data, right? So what is this data, and where we can collect it, and how to process it, how to distribute it. So these questions, when we want to build up this new platform, we need to think about it. There are some of ongoing movements on our campus. As we know, we have this mobile app. Everyone from ASU, they use it every day, right? You can use that to locate a resource and use it to check in and to report your health condition, etc. You can also use that to report connect to the on-campus police department directly, right, to report instance. So in addition to that, you can also see there's the blue light posts all over campus. And this one movement is that we want to renovate all these on-campus blue light posts and try to incorporate all kinds of different sensors on top of it, right? So in that way, we can use that as a IoT platform to interact with a passenger who pass through the campus, or using that as an interface to interact with students or faculty or visitors. Okay, so then we try to see how we can start with, right? So we want to look at a fundamental application that we can use as a showcase, right, to build up a prototype. First, we look at this video surveillance service case study. Right, just assume, right? So every blue light post have a video camera as a surveillance purpose, right? So the question is, when you use these surveillance cameras, you can collect data, and but however, the privacy issue will be, can you release? You may release or you may reveal the human information, sensitive information, such as if you have a high-level privacy considerations, you may now want to tell who are those people, right? So you may look at the face, right? And based on the face, you can recognize who she or he is. Other information you may want to also hide, such as hide the to make it not different from what kind of clothes the people are wearing, or anything which is related to any specific feature for the hookup with a human. So the idea is that can we build up a distributed data processing model, right? Just emulate this surveillance video sensors which belong to different entities. And then we can utilize the distributed computation model and then privacy protection model together, right, to preserve the data rights from the data owner. At the same time, we allow data users, such as machine learning companies, to utilize their data to build up a better or more accurate machine learning outcome, such as to improve the accuracy to identify a human based on the face recognition, and then try to blur or anonymize the face information and in order to remove the personally identifiable information, right? So based on this, bear these requirements in mind, we develop a prototype as a showcase. So here is an example. I just want to highlight, on our campus, we may have a lot of video cameras can be distributed all over the places. And in our current situation, we have the campus SDN or software-defined networking structure, right? So although we have this highlighted structure, the traditional structure is still there, right? So we want to replace it, down the road in the future. We also have our ASU data center and the police department. So as right now, I believe all our data are collected in central place, and they are sitting there, and nobody care about it because due to the privacy issue, it's not be reachable, right? So later on, how we can utilize to improve the on-campus life, right? So in addition to the surveillance type of video applications, we know there's many other applications, right? So we can use the video to monitor the traffic on campus, right? And also provide instant help to a particular human, using the video as a interface, right? To provide better on-campus services, right? So there's many other applications in addition to the surveillance type of application, right? So we look at a new architecture and try to incorporate a new cloud computing infrastructure. We call it the edge cloud computing. So in this picture, it shows a rough, structure, tells you the basic story. We may have a number of video surveillance and installed on these blue light poles as an example. And there's a subsite, geographically they are located very close to each other. They can become an edge cluster, right? So they connect to an edge computing resource. We call it the edge node. So an edge node could be a cluster of physical computers, right? So you just consider it as a small scale cloud. The reason you want to do that because you can move the computation power as close as possible to where the data is collected, right? And provide real-time computation support to process data and analyze data, right? So this is a new development trend for cloud computing solutions, right? So basically, we decentralize the centralized cloud computing into a distributed fashion, right? But we still have our ASU cloud computing, in our research computing facility. We consider those facility has a huge amount of computing resource, right? So the idea is how we can utilize this edge computing structure to build up a decentralized machine learning infrastructure, right, to process data. Okay, so this is from the computation perspective. We can also do the emulation, such as each edge node is to emulate a data owner, right? Suppose your organization have a set of surveillance videos, and you maintain your own data set, and you have your own small cloud computing resource, right, for computation purpose. And then the machine learning company, like a data user, they can be at the centralized cloud, such as the ASU cloud side, right? So they want to see if I'm running a specific machine learning algorithm, I want to push my running code, right, by using a divide conquer approach, right, and partition my algorithm into multiple levels, right, and a partial of the computation can push to the edge, and then I can get the intermediate computation results and to aggregate them to generate the final results in a centralized place. Okay, so in this way, I do not have a direct access to the data resource, right? But I still have a way to indirectly process the data, right? So this is kind of like an outsourcing approach, but this outsourcing is from centralized to kind of like a decentralized computing environment. So the supporting architecture we are using is a software-defined infrastructure because we want to make this programmable, right? Using the software-defined approach to enable the on-demand process, and using the edge cloud computing infrastructure and build out the edge nodes, right? And then and see how we can support the IoT platform. So let's look into a little bit in details regarding to the edge node and the Bluelight pole infrastructure. So from this picture, you can see on the Bluelight platform, basically it has a smart gateway or smart switch on it. It has a fiber connection, which is have a link connect to the edge node. And it has a local policy or rules, such as the access control policies. And it has an IP enabled interface to support those sensors or videos, right? So this interface allow you to interact any, interconnect with any sensors you want. Right? So this is a Bluelight pole structure. So within the edge node, you can see it has it uses like a virtualization solutions to construct a multiple computation. We call it condos, right? So you have a kind of like a isolated computing environment, which can be used to dedicate for a particular computation task. Okay. Then you have a local controller to manage the resource within this edge node, right? And to allocate sufficient resource to support each condo related computation, right? So, and all this computation must be handled within the edge node's memory, right? So later we will talk about this in-memory data processing module. So on the sensor here, just enumerate different type of sensors from environment, from subject, object, monitoring, communication, and the powers, right? So this could be different numbers. The enabled technique, here again, edge computing, IoT, decentralized distributed federated computing, software-defined networking, and the network function virtualization, and then finally how we can run machine learning in a parallel distributed fashion. Right? So this is a supporting technique behind it. This is another recent research article. It's a survey. It's regarding to what is the challenge for machine learning for IoT security. Right? So for this blue area, this is a common classification for different solutions from machine learning, from the security, and from IoT aspect. And we want to focus on more on the future research challenge, especially in the red circles, right? So we identify some challenges here our prototype try to tackle with. The first one is a challenge for deep learning in the edge, right? So how we can partition our deep learning algorithms into multiple stages, right? And allocate these different stages on different hardware. So partially on the edge and partially in the centralized cloud, right? So in this way, we can separate the computation for data owner and the data user, right? So this is the separation is one of our focus. Another one is the efficiency of machine learning, deep learning based security solutions, okay? So one idea is that we want to push the computation as close as possible to the edge. That's one idea. Second idea is that we are not using centralized cloud to handle all the data, right? So we want to distribute, we want to using the divide conquer approach, right? Because suppose on our campus, as far as I know, we have more than 700 blue light poles. Okay, so if you have a video camera on every pole, and how much data you will collect for every second, right? So this amount of data you cannot do the centralized computation model and to run it, right? So you need to use a parallel computation model, right? So using edge cloud computing is an ideal platform. You have a relatively small number of video streams, which is handled by the edge nodes, right? And then you can do this parallel computation model, and then as a centralized node, just aggregate the computation results from these edge computing nodes. The last challenge is unavailable data set, right? As I said, it is a data islands problem right now we are facing. Using this decentralized computation model, and together later we're going to talk about this in-memory computation and encryption schemes, right? So we can, at a certain level, to preserve the data privacy for both data owner and data user, right? So in that way, we can break the barrier, right, of this data island issue. Okay, so this is what we want to achieve. And this slide is try to summarize, what is the design requirement, and most of them I think I have already discussed, such as real-time issue, right? So we want to make it close to the edge, and using a decentralized model to do this parallel computation and make sure we have sufficient resource to do the computation in the real time. And using the cloud computing, we can make this more elasticity, right? Based on the computation jobs requirements, we can allocate corresponding resource accordingly, right, to support the real-time computation. And also location aware, because it's edge computing, right? Depends on the location, you allocate the resource. We focus on the security and privacy, and eventually, right? So we hope the CREATE platform can be used not just for surveillance applications, but also can support many other different IoT data collection processing, right? And serve as a research platform, right? Allow researchers to utilize data, right? Based on the privacy preservation model. So any data owner willing to provide their data for building up a new machine learning results, right? So this is the goal, one of the goal for this work. So this is a pilot application scenario. We want to see, based on the platform, what is the other pilot application scenario we can think about it. So here I just enumerate a few, such as the distributed video surveillance we just mentioned, and safety-related transportation, sustainability, environmental monitoring, and mobile computing, mobile applications, and smart campus monitoring, such as traffic monitoring, right? And vertically, there's a number of metrics we want to see for this. What is the criteria for these different for these applications, such as time constraints, location constraints, computation constraints, and data collection. So each of them could be handled by these components we just mentioned, such as distributed computation platform, edge computing, cloud computing, and privacy security protection module we established. Okay. All right. So the approach is we use a network resource management through the software-defined system, right? So in this way, we can create a dedicated computing and networking infrastructure. Usually we call it as a slice, right? So a slice including a set of a computation and networking resource, which is can be used dedicated to a particular application. Right? So in that way, you can have a dedicated resource to support the data transmission, data allocation, and also data processing. Okay. Also, we need to build out efficient metering and measurement, right? And to provide feedback and tell the controller to know if you want to provide more resource or if this is sufficient or not, right? So this gives you a kind of like a elasticity, elastic, I don't know how to pronounce it, elasticity, right? So make the computation model, right, which is can allocate according to the real need, right? So to enable the data-driven based innovation, right? So by developing these new distributed parallel computation models to support edge-based computer services, right? Finally, our development, we want to create an openness of the data. In a sense, we provide the privacy protection and sanitizing, right? Because we want to use the video surveillance model as a showcase, how we can anonymize the human's face, right? After we finish anonymization, so the data set can be used not only by researcher, right? And by the internal or third party user who want to use the data to build up their own machine learning model, right? So this is the goal to make the data clean and without privacy issues in there. For distributed deep learning, so this picture shows architecture we are trying to establish. So from this picture, you can see on the right-hand side, right? So this shows the infrastructure of the edge computing, right? So we have edge nodes over here, and then we have a local access network which is connect to the edge, right? So you can consider this as edge node, right? Which is running this programmable networking. And then we have a data center. This is kind of like a 3-tier infrastructure, right? So build up this data collection and data processing and distribution model. And on the left-hand side, or in the middle part, you can see we can partition our deep learning algorithm into multiple stages, right? We can push some of our computation if we have a smart edge device. Definitely, they can do initial computation, right, by running this machine learning algorithm. And then in the middle, basically, we can run another layer, right? According to the level of depth of this machine learning training or measurement model. So we can somehow decide where we can exit, right? Exit means that if the outcome, at a certain level is fulfill the accuracy, right? When you want to train the data, basically you can exit without going to the top level, right? So it's kind of like a elastic model you can establish within the machine learning architecture itself, okay? And so basically, when you look at this, you can see which part belong to the data owner and which part belong to the data user, right? So in this way, we can see what the raw data is at the bottom, right? And then the process data is at the top, right? So in that way, we can partition the data access for data owner and the data user. This is the edge node. The architecture edge node basically is from the operating system aspect. We have the network interface at the bottom. And of course, you may have a GPU to support the graphic-based computation. In the middle layer, this is a software-defined network architecture. There's many software networking components out there, right? So you can use, right, implement. And on top of it, we have the virtual interface. And then you can have a virtual machine or container, right? Depends on at what level you want to componentize the computation resource, right? And each of them, you can create like a slice within the edge node, right? And the runtime algorithm should be in the memory, okay? So we can use the trust computing model, right? So use a hardware to validate a chain structure to make sure the software are not modified by a third party, right? So in this way, we can guarantee the running software component in the system is secure, right? So then the in-memory computing model should be running within these condos, right? you can consider this one of the multiple application use cases, right? And the memory should also be encrypted, right? And now we need to decide who owns the encryption key, right, in order to reveal the data content, right? So that is the key research part we try to figure out to better support the user's privacy. Yeah, before I show the data encryption model, so this picture shows the data processing model. So suppose the video traffic come into the pipeline, right, coming to the edge node. Then we need to run the data pre-processing module, right? And based on the traffic tag, first you need to put tag on the data, right? So based on the tag, then we can perform further computation. The next model is the data sanitization module. So basically, it will run the machine learning model to identify the sensitive private data, such as human face, right? So if you identify it, then we can anonymize it, right? By blur it and or change the face, right? So there's some recent work, right? It's very interesting, try to change a human face with different shape, right? So although it's you, but you look like a different person, right? But for this sanitizing purpose, you know, if we just blur it, that'd be sufficient, right? So depends on which level of anonymization we need. So after that, the processed data will be encrypted and stored in the local repository, right? So you may want to use that for future, or you can use a real-time, can be sent to the real-time applications or services to use those data. Okay, so everything running at this level, we need to run in-memory model to perform encryption, decryption, right? And then we need to manage the keys in order to let which party will be able to access which part of the data. So here's a very busy picture to show the encryption schemes, because we have trust structure, right? Initially, we know using the trust computing model, it has embedded encryption key in the hardware, right? So this is produced from a manufacturer. And also we need a third party who is running the real-time verification services, right, to validate this hardware associated key. And then on top of it, we can build up an individual encryption, decryption key. So this can, you can consider such as if you are a data owner, then you need to work with this trust infrastructure to generate your own key, right? So you can validate your own key or public key from the trust party within this trust framework. And later, you can also negotiate a shared key with trust with the data user, right? So for those shared data, both the data owner and data user use a shared key to do the encryption, decryption within the memory. Then for the part only the data owner can see, right? So we just need a temporal shared key between the trust platform and the trust owner and the data owner. Okay, so in this way we can have many different keys, right? So from here you can see we need to have many different keys which is generated, right? And each of the key are used within this infrastructure to guarantee which part of data is encrypted and who can review it, right? So no party in this infrastructure can reveal the entire key, right? So such as the data owner can only see the raw data, and the data user can only see the process results, right? So all this operation is happening in the memory. So there's no key managed or stored in the hardware, okay? So for the attack model here, we assume who can compromise the system, right? Basically, the attack model we consider, we call it curious but honest. That means, for example, if you use system maintenance like IT stuff, right? So you may have access to the server, right? You can log into it. But however, these guys, they are interested in the data content, but however, they do not want to implement a real attack software into it, right? Try to compromise the key, for example, or try to using some of buffer overflow problems to get inside memory to prevent from encryption, decryption, right? So those are very sophisticated attacks, which we consider is not possible, right? But they have access to the system, they have access to the software, but in order to get into the memory and to decrypt the data, we consider it's difficult, okay? Also, the last thing I want to say here is for the encryption key, they are temporal keys, right? It's only in the memory. They are only valid for a certain small time period. So after that, they are discarded. So in that way, we can provide better support in terms of security. In terms of machine learning or deep learning infrastructure. So here, I just show a picture to show we have a multiple computing model. So in here, we have a data, right, such as the data collect from video surveillance sensors, right? So here we assume there are 3. And then each of them have a local computation. So they send out update intermediate results into the centralized place. So here we can see that as a data user to collect these processed results and then to combine them together in order to generate the final results. And then they send the update back to the individual nodes, right? So in this way, you can have an iteration of multiple rounds of computation to improve the training results, right? To give you a little more visualized structure, so here we assume we have 3 nodes, edge nodes, right? And each of them, they run the well-known machine learning training module, right? Try to improve the accuracy to identify the human face, okay? And then there's a number of procedures, right? So this is temporal intermediate data will send to the primitive server, right? So where the data owner will be able to aggregate all this data and then send feedback to the edge node, and then they can continue to process. So within the memory, when we look into the deep learning algorithm in more details, right? So you can see it's built up on a neural network. It has multiple levels of operations. So we can partition the number of layers into 2 segments. So the first a few layers, we can assume this will be accessed by the data owner, right? So we can use a special key such as MEK, right? DO represents data owner. So the data owner will be able to understand the data content of this part of the data and to do the machine learning and train it through multiple layers, right? And then on another side, so this part is use the data user's key to encrypt the processed data results, right? To continue to finish this training, okay? In this way, we can partition the machine learning algorithm for data owner part and the data user part, okay? So finally, we did the evaluation based on simulated data set in the Amazon AWS servers. So here we set up a prototype using like 6 different edge nodes, right? So we use existing well-known image data set or video data sets and create like an incremental case. Because our assumption is that initially the data user does not have sufficient data to train the model. It may have a very limited small data set, right? And gradually they need to acquire the data from the data owner. So we call it as an incremental training, right? So gradually you can improve your training results to reach to a good and satisfactory level, right? So in that way, we emulate the situation, with a 3 incremental training process, right? So in this way, we can see how our solution compare with a purely centralized location, right? So there's 2 case studies. One is we're using the proposed edge cloud computing, 2-level structure, centralized and data edge cloud, and using this encryption, in-memory encryption approach to do the training, to compare with everything in a centralized place, right? So we consider that as a ground truth we want to compare with, right? Ideally, this decentralized computation training should be as close as possible to the centralized training, right? But we know in the centralized training, we do not have any data privacy preservation, right? So in this way, we want to see if this decentralized training and machine learning processing framework will be useful, right? So some results shows, the first case is that if we have a fixed number of training input video streams, right? So you can see the centralized and decentralized is very close, right? So the red one is our approach, and the blue one is a centralized approach, right? So in these 2 cases, we have 2 case studies. So the FID score basically is a measure of accuracy of face recognition, right? It depends on the percentage of face we can successfully to identify using a centralized or using a decentralized training approach. So in the second approach, second case study, we want to measure for the training, we can have a fixed interval, right? Because this, due to some of the delay, we may make some of a situation which is within a fixed interval. The edge node cannot finish the training, right? So that means that some of the cases, the training results are lost, right? So that's possible because if you have multiple nodes, right? You want to collect the data from multiple locations. Some of them may lack of a resource, they cannot handle it, or maybe due to some of the failure issues, right? So data may miss. So in that case, though, some cases for some cases we have seen it's also very close, right? So if it's just missing 1 or 2, it's not a big deal, right? So our case are still close to the the accuracy of the light approach, right? So, but if you have more than because we have 6, right? So if you have more than 3 or 4 known fields, right? So the training accuracy will be dramatically reduced. Yeah. So finally, we want to mimic the basically the case 3 and the case 2 are similar, right? In the case 2, we have a fixed interval, right? And in the fixed 3, we assume these are failures, right? And there's no contributing worker nodes, right? So the result is quite similar. Finally, this curve shows the comparisons between in-memory performance versus if we do not use in-memory, right? So the blue curve shows the performance in terms of a delay if we store the data in the storage, right? It's due to I/O operation compared to in-memory operation. So it's very consume quite a lot of delays, right? So definitely we prefer in-memory operation. But the downside for in-memory operation is that you need to have a sufficient large amount of the memory, right, to host all the data, because you need to create a storage structure within the memory, right, to emulate the storage on the hard drive. Okay, so but I think this is a trend, right? So we need to process everything in memory instead of store it on the local drive. Yeah. So finally, here just a few thoughts. After this work, basically we may consider the privacy. It is a appliance. It is also a protocol, and eventually it is infrastructure, because when we design this infrastructure, we consider the privacy as a main consideration, right? So why we use edge computing and use in-memory encryption and using distributed deep learning. This is all because we want to achieve a certain level of privacy to protect the data owner, like data ownership, and also to protect the data model sent from the data user, right? So these two parties we consider. Also, the data island challenge demands a significant efforts at the infrastructure level. Okay, so for the future IoT platform, I believe we need to have a reliable and trusted infrastructure to preserve the data privacy. Right, so if we cannot do that, the data island issues will be always there. Okay, so finally, the development of machine learning and AI and data-driven science solutions can greatly promote new privacy solutions. Right, so I believe if there's a good solution come out and it can significantly improve the machine learning and AI solutions, and as a return, that can also greatly help the new privacy solutions to come into the picture. So that's why the privacy infrastructure research and the development is very important. Okay, so then this will conclude my talk. I think I'm within the time range, and I'm ready for any questions.
Yes, definitely. Thank you very much. I don't see any questions yet in the chat. Feel free to add one if you have one, or we're a small group of looks like about 20 people right now. So if you'd like to unmute and ask a question, you're welcome to do that as well. While we're waiting to see if anyone does have a question, one of the things that came to mind as you were speaking for me, Dr. Huang, was how this model affects reliability and redundancy. So is the decentralized model where it's working with information in memory, is it less fault tolerant than a centralized model that uses data from disk?
Yeah, I think to my understanding, for the decentralized model, definitely may introduce a more reliability issue. Because if you have everything in a cloud environment, right? So no matter what, you also need to do the parallel computation if you have a large amount of data, right? So you still need to partition the data set into multiple smaller data set and to run this parallel computation model. But when we have this edge computing, so the parallel computation is not closely happened, next to each other, right? So within the data center, you need to using a reliable network and a reliable edge node, right, to do this parallel computation, right? So I think the reliability issues will become more severe compared to the centralized. But if you consider as a disaster, that's a different story. Right. So if you have a disaster, data center itself is gone, then definitely it's not work out. But in disaster scenario, I guess the distributed computing will be better, because if one edge node fails, right, you have many other edge nodes can also provide you the resource. So yeah, I think it depends on what kind of consideration or issues we are dealing with.
Thank you. We do have a great question in the chat now, and I don't think it's simplistic at all. The information you shared was pretty deep, some of it. So Andrea is asking, though, if the facial recognition images crosswalk with an existing database of photos and IDs. And that's a great question, because you probably don't have a ton of storage on the edge nodes replicated to each one. So how is the facial recognition really done?
Yeah. So for our current training data set, I don't think we have the scenario you have a crosswalk with like a face or photos in that particular setup. So that's the point of our work, because initially we assume the data user have a very limited data set, right? And gradually we hope the data owner can share more data set and can continuously to help us improve the face recognition, right? So definitely these are the false positive, false negative cases, right? So if we can identify that and from the data owner, right? So they may introduce all kinds of scenarios as they collect data with different background and set up. So then the eventual goal is try to improve the accuracy as much as we can, right? But the challenge right now we're facing is data islands issue, right? So you don't have data. If you have more data, definitely we can try that. So in our current prototype, I don't think we, at least I don't see this kind of data with crosswalk and the face together.
Okay, that's great. And actually, I remember learning about facial recognition being effective when you're really looking for people that aren't supposed to be there. So that probably is a smaller data set than just the entire entire population of an area. We have another question from Ted. What do you think the necessary steps are going to be to combine privacy and automation, preserving privacy in the AI ML DA space?
I think it's like a real-time type of application. Definitely, you need this automation and compare privacy. So for video surveillance, I think that's probably a good application scenario we can think about, such as if you have some like an on-campus incident, right? You want to do a real-time face recognition or maybe image recognition to identify some potential subject. So you need to run this on the fly, right? And definitely I think another situation I can think about, such as autonomous vehicles, right? So maybe is another situation. The key of the AI, one of the key AI is autonomous, right? So you need to automate all this procedure and combine machine learning algorithm with real-time decision models. So that is definitely the situation I can think of.
How about a lot of the early material you shared, the UTO team built or contributed to, and the Smart Cities direction. As you assessed the materials that or the work that we've done, were there any gaps that if you knew we focused on, that it would help your research, or things that we could contribute as we deploy technology?
Yeah, definitely. Right now we have some of the barrier in terms of to implement a real application scenario or setup. So all our current prototype is built within the Amazon's AWS. We emulate there's a number of edge nodes, right, and also centralized nodes to run this decentralized computing. But if we have the access to the a Bluelight platform from UTO can provide to us, definitely we can have the field data. And also, if we have the video cameras and collect data, definitely we can have more resource to improve our machine learning and as a showcase, right? So I hope this can happen. I know there's some barrier in terms of the data cleaning and policy security concern issues. But definitely if we can help to address that problem, we can do our insight evaluation. So I'm waiting to work with any folks from UTO and to see our future development and also the prototype and see if that works well in a real setup.
Great, thanks for that question, Chris. I saw Ted come on camera for a minute. Did you have a follow-up question?
Yeah. Am I unmuted now?
You sure are.
There we go. So, respectfully, I think that the concepts and concerns about privacy in the public safety space kind of take the backseat to the fact that so long as there's signage, right, and or people are made aware that they're going to be under video surveillance, you kind of give up your rights to privacy with respect to your image being captured in a public space. My question is really not focusing on the areas of video surveillance and public safety and physical security. What I'm questioning, I like the concept of, privacy as an appliance or a protocol working on an infrastructure platform. I do try to follow the robotic platform as a service and the integrated platform as a service concepts. And I'm concerned that if you look at the way some vendors are approaching automation, data discovery and access to information and records is something that they do organically, right? Whether you're saying we are process driven, we're going to have a bot that's going to do tasks that are going to simplify something for our end users. Like we're going to run an HR bot. And the HR bot's going to let us know whoever has vacation coming up, and we're going to talk to the email bot, and we're going to generate a form letter, and we're going to let everybody know, and then we're going to talk to accounting and make sure that there's an alignment of HR data, time off, compensation schedules, accounting, and and everything else, right? That's all great stuff. But at some point in time, these different agents, software agents or bots or whatever you want to call them, are traversing different systems. And unless you go in and put controls in advance, how can you stop optimization from compromising privacy? And that's just one particular use case. Imagine if you're automating a process in healthcare, right? So what are you guys doing in that space in terms of your privacy as the platform, which I think is fantastic, by the way. So I'm genuinely interested in your response to this.
Well, I think this is a very, very big question. So it's not easy to answer in one sentence, or maybe a couple of years research effort.
Okay, 4 sentences. 4 sentences.
So from my own perspective, I think we do need a new privacy infrastructure to handle the fundamental issue of the privacy. So if we rely on the existing infrastructure, definitely there's no solution, because when you make a business with any entities, you need to give out the information they need. If you don't give out, then you cannot enjoy the service, right? So that is trade-off you need to think of before you give out your privacy. But if we have a good privacy infrastructure, at the first place, it can prove if you're using it, right? So at what level your privacy can be preserved, right? And all applications built on top of it, then you can use it, So to address the exact problem you just mentioned, to be honest, I don't have a good solution for now. But I do think if from the research aspect, we do need to think from the entire infrastructure, from the protocol, from the framework, right? From everything to consider security and privacy as a fundamental building block instead of as an add-on. Then we can address it. Right?
Okay.
So,
very good answer. I mean, today, in fact, I received a phone call from Sleep Number Bed, unsolicited, like a spam phone call. And it occurred to me that maybe my thermostat was talking to my mattress and telling them that I actually needed to buy something new, right? I mean, there's too many intersections between IoT devices, technology, and capabilities. And I really appreciate the fact that you have been brave enough, and I don't want to be a sycophant, but you're brave enough to take on privacy, because That is not something that most of these vendors and manufacturers and problem solvers have ever considered. They're so busy high-fiving each other because they were able to get the toothbrush to talk to the cell phone to remind me to make a dentist appointment, that they forget about all the different tenets of PII that are involved. And that's just the personal story. Can you imagine if this is organizational, like at ASU, where student records were inadvertently shared and published in the, but because they were trying to save money on environmental services, right? When they were talking about how many people were in the building at a certain time for a certain class, and so on and so forth, and everything, gets thrown in. How do you begin to approach privacy then when you're building your platform is my follow-on and final question.
I may just give one example based on today's talk, right? So because for the specific sleep number questions, I know what it is, but I have no concrete solution for that or answer for that. But what I can say is that based on the solution I propose here, because we want to address these data island problems. So the fundamental issue is the data sharing, right? So traditionally, when you want to share data, right, so you need to give out the data ownership, right? So now we try to build up in structure, right? We tackle this problem, trying to see how we can build up in structure, which is do not need to share data, but still you can involve multiple parties to do the computation. So basically the foundation is based on the multi-party security computation solution, right? So definitely this overhead will be involved because it's very complicated. You can see there's so many technology are involved to make this infrastructure happen, right? So I believe for a different domain, when we look at the problems, first we need to understand what is the fundamental security and privacy issues out there, right? And then can we look at from the fundamental issues such as the data sharing or data processing, right? Instead of from application to see how we address it, right? So if we address data sharing, data processing, and data distribution, right? So all these questions, then we'll want to see how we, to support a specific application. That might be the direction from research aspect we can look into. Right?
Yep. So, thank you.
Sure. Thank you for asking a question.
Great conversation. We have some thank yous in the chat. I don't see any other questions. So I think we're probably ready to wrap up. Thank you so much for being here today and sharing this information with us and answering the questions from our community. And we do have another session coming up in March. It is about B2B process automation and using the public mainnet as a common frame of reference. So stay connected, and thanks for joining us, everyone, tonight.